All right, hi guys, so this is Miss Davis, and we are looking at page 6 and 7 first for today. The first couple things, pretty easy, just define them. Collision theory, again, just where those particles are actually colliding, having more energy, the more collisions that you end up having, and I'll have an answer key and everything for you posted later. This is just kind of your help video. And then as you kind of move down, one of the questions that I was getting was definitely on number 6. Okay, and so it talks about having activation energy and when you're looking at the curve. So when we're talking about curves, we want to go back to page 7 really and looking at this kind of graph. Sorry, it's a little hard to see that graph. We talked about endothermic and exothermic reactions, and that's part of where we're looking at reactants and products. Okay. So just down here in this white part, I'm going to actually sketch it a little bit for you. So we talked about having a graph. So your X and your Y axis, and then you start low and then go really high like over a roller coaster, and then you end up higher than where you are. And then the other type of graph, same thing. We start higher, we have a little hill to climb, and then we come and we end up lower than where we are. So one's endothermic and one's exothermic. This one is endo, okay? This one is exo. So endothermic, your reactants are very, very low in energy, okay? And then endo means it's gonna take that energy into it, so it's gonna add it. So when you get way over here for your product, you now have more energy than where you started, okay? Now, if you're an exothermic reaction, you're already pretty high. You have energy that's stored, so that potential energy is really high. And then as you are an exothermic, exo meaning that you're giving it off, okay, so like a fire, then you're going to put out energy, and continue to give energy out. So then at the very end of your product, like if you were burning wood, you have ashes. The ashes don't have as much stored energy as the actual piece of wood or firewood does. So your products now have lower energy. And that's all they're really wanting you to do for that question, okay? So some of the questions that we need to kind of look at are the numbers that they give us. So here on page 6, we are looking at 22 kilojoules, and then it says the total energy change, sorry if you can't see that, kind of have to move over just a little bit, right? It says negative 103. So that means the difference between the products, or the reactants, and the products basically. So from the reactants to the products, it had a change, okay, of minus 103. So if it was minus, remember that we talked about, that means, okay, that remember the negative was for exothermic because it gave up that much energy, okay? So when they want you to just sketch part of that graph, it should look very high for your reactant, and then it should be in give off. Oh, now my products are way lower than where I started. And that's all they're really wanting you to do is kind of think about it. The same kind of question is up here for number 7 on the top of that next page, okay? So same kind of thing. And then really understanding all of the parts for this, and we can go ahead and do that on the questions right now. So for reactants, okay, so your reactant should be B right here. For your products, it should be C, so your C way over here. The energy of the reactant, so it's how much energy you have. This right here, that's the amount of energy. How high is it off of that 0 line from the graph? So number 1, energy of the product would be 4. Activation energy, okay, so the activation energy that it needs is going to be from where they start, okay? So how big this little hill is they have to get up, that activation energy. How much of a kickstart do they need to get over to the product side? So that's going to be number 3, okay? And then what we're going to look at for change in H for the reaction, it means the difference. So where did I start at number 1? And where do I end up at number 4? So how much change did I have? If I start with $5 and now I have $20, well, I changed by 15. So that's all it was really asking. So your change is number 2. And then activated complex is the name for basically the entire kind of graph, but it really kind of pinpoints it at A. So A, the entire amount of energy where you start, how much activation energy, and how much energy you have at the very end of this reaction is all called the activated complex. And hopefully that was a little bit more helpful for you, okay? We'll work on some of the other pages in another video.